Alright, this is 1.6 homework. First problem wants to solve this fourth degree polynomial. Now, there could be up to 4 solutions, right? This thing looks like that. So we'll see. You can find it from your calculator, obviously, by graphing it and doing the second calculator 0, but let's try to do it algebraically. So let's try to factor this into two quadratics. Minus 3 and minus 2 would do it for you. You just guess and check. Pretty simple one because there's only a 1 here. Now, set each of these factors, x squared minus 3 equal to 0, and add 3 to both sides, you get x squared equals 3. Square root both sides, you get x equals plus or minus the square root of 3. And then here, same thing, add, set this equal to 0, so it'd be x squared minus 2. So you're going to end up with plus or minus the square root of 2. So it wants the increasing order. So the smallest one would be the biggest negative value, which would be negative square root of 3. Then it'd be negative square root of 2. Then it'd be square root of 2, and then it would be square root of 3. Let's try the next one. Cubic says find all the real zeros. There could be up to 3, right? Because it could be like that. So we'll find out. Let's try to factor it and do it algebraically. If we factor it, we get x squared plus 3x minus 28. And then we could try to factor this one again to 2. If we can think of two things that multiply to be negative 28 and add to be 3, like 7 and 4. So positive 7 and negative 4. If we do that, then we get x equals 0, negative 7, and 4. Alright, next equation, we're just going to add 9 to both sides. We get x to the 4th equals 9. Then we can take the 4th root of both sides. And when you take the even root, you always have to do plus or minus. So we have the 4th root of 9, which on your calculator, there's different ways to do it, but one of the ways is to do 9 to the 1/4 power. And then just do the positive and negative. It wants a to be the negative 1 and b to be the positive 1, or whatever that gives you in your calculator. Okay, next function is a 4th degree polynomial. It wants the y-intercept. Y-intercepts occur wherever x is 0. So if you plug in 0 for x, you get 0 for y. So it goes through the origin here. The x-intercepts occur where y is 0, so we're going to have to solve that. We'll try it algebraically. If you factor out an x squared, then you're left with x squared plus 3x minus 28. And you want to set, so we know x equals 0 is one of the x-intercepts. But we also might be able to factor this into two linear factors. So it'd be x 7 and 4 again, so plus 7 minus 4, and so you have negative 7 and 4 again. Okay, and now the last part says if x goes to infinity, what does this thing look like? Well, it's a, we know the zeros are at 0, negative 7, and 4, so we know this thing looks like this. We've already actually done this problem, I believe. It goes like this. And the question is, what does it look like way to the right? Well, to the right it goes to infinity, and way to the left it also goes to infinity. I think it wants just a plus sign there, plus sign there. Another problem that we've done, but you might easily forget, is if you call the square root of x equal to w, then x would be w squared. It's a little trick to realize that this really is kind of like the quadratic pattern, where now x is w squared if you sub it in, and square root of x is really w. Now it's easier to see that this is really a quadratic. Now you can factor it. W and w, you want minus 6 and plus 1. So we have two answers. We have w equals 6. And we also have w equals negative 1. But w was really the square root of x. So we can square both sides. And we get x equals 36. Square both sides, and x equals 1. So two solutions, 1 and 36. Okay, other types of equations. The next one is the square root equation. It has one solution. If we square both sides, we get x squared equals 1 minus x. And then if we add x to both sides and subtract 1 from both sides, we get this. We can try to factor this. Are there two things that multiply to be -1 and to be +1? No, there's not. So it doesn't factor. Let me try using the quadratic formula then. Opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. So double negatives go positive. Before, so it'd be 5 underneath here. It'd be 2. So it has one solution. So one of these is going to be extraneous. One of these isn't going to work. And I'm not sure which one, but you're going to have to try both of them. My guess is the positive answer won't work because of the 2 that you get here. The positive one is going to be a negative underneath the square root, which is undefined. So you're going to want to do the -1. -1 minus square root of 5. All over 2. So you can enter it in, you know, like this, only you got to use square root here. You got to make sure this whole thing's in parentheses. All right, the only way to do this one, you're tempted to square both sides, but you can't because you have to FOIL everything. So the only way to do it is to make it square root of x plus the square root of 2 times the square root of x, which you can do. You can break the square root up into two things individually when you're multiplying. And then factor out a square root of x. And then subtract the square root of 2 from both sides. And then square both sides. So there's your one answer, x equals this 1 minus square root of 2 squared. You can probably enter it in like this if you want, and it should give you the right answer, or you can do a decimal. Next question said you build a box that is 4 feet long, 5 feet wide, and 8 feet high. So I'm going to draw this box here. Okay, so this thing is 4 feet long, 5 feet wide, and 8 feet high. Obviously not drawn to scale. The distance from the top left front corner, which is this corner, to the top right back corner, be this one, is question mark. So basically I have to use Pythagorean theorem a few times because I have a right triangle in here, right there. It's a little hard to see. But I need to find the hypotenuse of this triangle. You can see that at all? It's a right triangle as well. So if you do 4 squared plus 5 squared equals c squared, I can find that distance c right there. So square root both sides. That gives me c, whatever number that is, 16 plus 25, 41. So the square root of 41 is that distance. This distance is 8. So now I have to do the Pythagorean theorem again to find the hypotenuse. So it would be c squared, which is square root of 41 squared, which is 41, plus 8 squared, which is 64, equals the new c squared, which I'll call z, just to give it a name, z squared. Square root both sides, so the answer is the square root of 41 plus 64, which is 105. Now, the distance from the bottom front left corner to the top right. I'm sorry, I actually found this one's the square root of 105. I actually found that one first. This other one I already did find though. It's the same as this distance. They're asking for the first one. They're asking for that distance, which we already found is the same as that, which is square root of 41. Next problem, you want to square both sides again. If you square both sides, you got to square everything. So that gets squared, and this whole thing gets squared. So it'd be 9 times x minus 1. If you square the 3, you get 9. If you square the square root of x minus 1, you get that. Now I can solve this by distributing 9x minus 9 equals 2x plus 1. Just add 9 to both sides. So you get 10 on this side. Subtract 2x from both sides, and you get 7x. Divide both sides by 7. You get x equals 10 over 7. All right, the next one, we're going to square everything again. So I'm going to square this. Actually, what I'm going to do first is make it square root of x minus 11 equals the square root of x minus 1. So I just moved the square root of x to the other side. Now I'm going to square both sides. Now you have to square this, you have to FOIL it. So don't forget to do that. It's an easy mistake. When you FOIL it, you get x minus 2 square root of x plus 1. And if you subtract x from both sides, these x's cancel. If you subtract 1 from both sides, you get negative 12 equals negative 2 square root of x. Divide both sides by negative 1. Divide both sides by 2. And then square both sides. And you get 36 equals x. If you try to solve it, that will work. All right, next one. I have fractions and an equal sign. Whenever you have fractions and an equal sign, you want to clear fractions by multiplying through by the least common denominator, which in this case is x plus 1, x plus 3. So when you multiply through by that to everything, it's minus 1, x minus 1, x plus 3. What happens is you get this x minus 1 cancels and you get x plus 1 times x plus 3 equals x plus 3's cancel and you get negative 4 times x minus 1 and then plus 8. So the whole bottom cancels there. That makes the equation a lot easier to solve. You know, distribute negative 4x plus 4 plus 8 equals x squared plus 4x plus 3, and this is really 12. Add 4x to the side, you get 8x. Subtract 12, and you get negative 9. And then solve that. So x plus 9, x minus 1 should do it. So it looks like negative 9 and 1. And make sure you check these because there's only one non-extraneous root, so one of these doesn't work. Okay? So definitely check it to find out which one it is. I can tell you it's going to be that one right there. So that's going to work. Because 1 gives an undefined answer right here. So it's going to be negative 9. Next one, once again, you want to clear fractions. So it's x over, if you pull out a 6, it's x minus 6 minus 3 over 1 equals 1 over x minus 6. So to clear fractions, you multiply through by this. 6 times x minus 6. And this whole thing cancels. You get x minus 3 times 6, which is 18 times x minus 6. And then the x minus 6 cancels and you get 6. So now distribute. 18 times 6 is 108. And then you can just subtract 108 from both sides. X minus 18x is negative 17x. Negative 102. Divide both sides by negative 17. And 102 divided by 17 gives you 6. Same thing for this one, multiply through by 3x to everything. And that gives you negative 21 equals 3x is canceled, you get negative 4 minus 9x. And just solve that. Add 4 gives you negative 17 equals negative 9x. So x equals 17 over 9. Okay, the next one, you can actually cross multiply this one. You can clear fractions by multiplying through if you want, but just cross multiply. It's actually a little bit easier in this one because there's only 2 fractions. And then just solve this. So subtract x from both sides, get x. Subtract 3 from both sides, you get negative 4. Okay, same thing here, multiply through by x. Everything, because you want to clear fractions by multiplying through by the least common denominator. If you do, you get this. So it's x squared minus 2x plus 1. And that actually factors into x minus 1, x minus 1, which is a perfect square trinomial, so x equals 1 is the solution. Alright, I hope this helps.